Hey everybody, this is Anne-Marie Fred. I'm a Senior Principal Software Engineer at Red Hat, and today I'm going to talk to you about CI/CD pipelines. This is geared towards beginners and managers, but I'm going to throw in a few interesting things for people who are typing and interface nerds or interested in the interoperability of pipelines as well. Let me share here. First, a little bit about myself. I have more than 20 years of software development experience, of which more than 10 years of that was working in a DevOps environment. So I've built quite a few pipelines in my time. I also spent 3 years helping out as a DevOps Days conference co-organizer, and I'm currently active in a couple products in the Linux Foundation and CD Foundation, including the Interoperability SIG and the Ortelius project. I spent 3 years as an HR manager, which helped me learn a lot about compliance and privacy and security regulations. I have been serving as a security focal for the past 4 years. Most of my career was at IBM, and I'm currently working at Red Hat. So there's a few things I hope that you can learn from this talk today. First, how you can get started with CI/CD pipelines. I want to give you some shared vocabulary around CI/CD that's coming out of the CD Foundation Interoperability SIG. I'll share the meaning of some common terms, and then we'll talk about what people often automate with their CI/CD pipelines. This can hopefully give you some ideas of what you might try if you're not doing some of these things yet. I'll talk about some interesting events, inputs, outputs, and side effects to expect from each type of step in a pipeline, and a little bit about how all this relates to DevSecOps and supply chain security. And at the end, I'll talk a little bit about some current research we're doing with making Tecton pipelines more pluggable. So this is a talk that's geared to beginners, but I hope experts will get something out of it as well. If you're a beginner, think about how you might use these different tools and techniques in your own development processes. And if you're an expert, please read between the lines and think about how you can help us standardize the inputs, outputs, and side effects of each of these tools and techniques to make them more reusable. Here's a little plug for the CD Foundation Interoperability SIG. One of the challenges that users face is the lack of interoperability across CI/CD tools and technologies. And this results in various issues while constructing and running pipelines, such as passing metadata and artifacts between the tools or achieving traceability from commit to deployment. And that's where a lot of this work is coming out of, and I have a link here to their GitHub site if you're interested in getting involved. So the interoperability SIG aims to enable a dialogue in the interoperability area by bringing CI/CD users together with the open source projects. And just a couple of things to highlight here. They want to promote the needs of the users who face challenges constructing these complex end-to-end flows using different tools and technologies, and also explore the synergies between and enable collaboration across the different projects. So why does a shared vocabulary even matter? Well, as a user of CI/CD pipelines, I want to be able to think and talk about them with people who use different tools in a coherent way. The DevOps world is open, there's many different tools and techniques. We don't want to be locked into one, and it really helps if we can share best practices with each other. And we also need to have one tool that's generating some outputs, another one that's consuming those inputs, so we need to have these tools understand each other. So if we can develop a shared vocabulary, this will help that in terms of like machine interoperability as well as human best practices and knowledge sharing. The catch is that many of these tools have been around for several years and they have devoted communities and they're comfortable with their own vocabulary. So they might not be willing to change, but at least we can have shared vocabulary so we can talk to each other more easily. At this website, the Interoperability SIG vocabulary website, you'll see things like common terminology that's used by CI/CD tools, as well as source code management tools, technologies, a mapping of terms, which I'll show you a little screenshot of later, between the different tools. So you can see, if this means step means the same thing as task in another tool, and also the shared vocabulary. So let's get into some basic CI, CD concepts. This is a bit of a fire hose. I'm just going to try to call out the most interesting bits about each of them, and don't worry, you don't have to memorize it because it's all on the website. So as a software professional, I want to automate as much of my manual toil as possible. Like software development, deployment, operations, and support, these all have many repetitive tasks, and they're boring, and they're a waste of time unless we automate them. So some organizations have people who specialize in such automation. They might have like a DevOps job title or like a pipeline automation title, but a lot of developers end up setting these up on their own as well. And they're usually using a combination of specialized tools like Jenkins or Tecton and hand-rolled scripts as well. So first we'll start with some basics: continuous integration, continuous deployment, and continuous delivery according to Wikipedia. Continuous integration is the practice of merging developers' working copies to a shared mainline several times per day. And it includes things like automatically building and testing your software. Continuous delivery is a software engineering approach in which teams produce software in short cycles, ensuring that the software can be reliably released at any time, and when releasing the software without doing so manually. Contrast this with continuous deployment. That's a software engineering approach in which software functionalities are delivered frequently through automatic deployments. So in continuous delivery, the software functionalities are frequently delivered and potentially capable of being deployed, but are not actually deployed. Now, people often use these terms loosely, which is why in the rest of my presentation, I pretty much will just say CI/CD, and it doesn't really matter in this context whether we're talking about continuous delivery or continuous deployment. A few more common terms. Pipeline is a sequence of CI/CD stages and steps that are used to automate any repeatable process, or it's basically an automated workflow. A stage is a unit of work that's 1 degree smaller than a pipeline, and these may be implemented sequentially, in parallel, or in some combination of both. And then a step is the next smaller unit of work, about 2 degrees smaller than a pipeline, and this is something you can think of that would typically be implemented as several lines of code. So here's an example of that mapping table that I was talking about from the website that I pointed you to. You can see, there's some consensus about what generally a pipeline is, but like Harness maps pipeline to a different level than the others, and some of them call it a workflow, right? Now, most people start with these 4 goals of CI/CD, and these are often implemented as your pipeline stages. We talk about build, test, release, and deploy. Those are the basic ones. So in the build process, we're going to download, retrieve, assemble, and/or compile our software or documentation into an executable and testable format. In the test phase or phases, we're going to test, scan, verify, and lint software and documentation, otherwise known as verifying it. In the release stage or stages, we're going to package, version, sign, and publish our software artifacts and documentation. And by the way, continuous delivery usually goes up to the release stage and stops if you're being proper about it. And then deploy, continuous deployment, is where you deploy your software artifacts and documentation to any environment other than the pipeline environment itself. And then you're going to verify that your deployment was successful. It's also sometimes called an install stage, especially if you are updating running systems as opposed to a system where you're constantly creating brand new systems and getting rid of the old ones. And here again is from the mapping table, you can see I've highlighted stage, and there's some general consensus that this is the same level of thing, although some tools will call it a pipeline or a task instead. Now, pipeline steps or tasks are where the low-level implementation happens, and that's what we're going to talk about most of the time here. Now, as a pipeline developer, if I know where to look, hopefully I can find pre-implemented, pre-tested steps and reuse them in my pipelines, but I may have to write them from scratch. It takes more time and effort for someone to write a usable step and share it. And this is one of the powerful things about open source, is that hopefully somebody has gone to that effort for you. In the worst case, I'll implement my own. And again, here's that mapping table. And you can see there's some general consensus about what a step is, but sometimes it's called an activity, a job, or a task. Now, pipeline tools usually make a few things available to developers from every step. This is kind of the power of the pipeline tools. They're going to pass you your environment variables and configuration parameters, so you can reuse the same steps with different configuration variables. You'll have a workspace where you can read and write files, a way that you can securely store and retrieve secrets that you need in the pipeline, a way to return results, including success or error codes, a way to control whether execution continues or stops from that step. You know, will it continue on to further steps or will it end right there? And then log storage and retrieval facilities. Now let's go through a bunch of different pipeline step types. First, a few terms that you might see in here. I'll talk about software source, binary source, generated software, and generated binaries. So software source includes all your human readable files that come into your pipeline, usually from your source code management system. Things like source code configuration files, documentation source files, your declared dependencies like your package lists, and baseline composition information like if you have lock files in your source control system. Then your binary source are executables that are inputs into your pipeline. Things like your executable software dependencies, your container images, and virtual machine images. The generated software is generally outputs from your pipeline, and these are human readable files like compiled software, generated configuration files, compiled documentation, and baseline or composition information that's been generated by the pipeline, like new lock files, or bill of materials. And then your generated binaries are executables that are outputs of the pipeline, like executable software, container images, and virtual machine images. Now, in the setup step, we're going to provision the pipeline resources and set up the pipeline workspace. Sometimes this is invisible to you because it's handled by the tooling. This is also called things like initialize, start, prepare, workspace, or orchestrate. And as an output of this, you're going to get your secrets ready for you to use, your pipeline environment, and your pipeline workspace. As inputs, you might have your triggers or your crust parameters, and maybe you're specifying the pipeline container image name and version, or what version of software of your programming language you intend to use, right? Interesting side effects, it might be setting up some persistent storage or another method for the pipeline steps to share inputs and outputs with each other. In the source step, we're going to copy software images and documentation into the pipeline workspace and also fetch configuration data. So this might be called clone or fetch, and we're going to get our software source and our binary source into our workspace. And as we also need a reference to which repository or branch or commit we're going to pull from in the source code management system. In the build step, we will assemble or compile software and documentation into an executable and usable format. And so this is where we get generated software and generated binaries in general. In a test step, we'll run a test suite. So examples of these might be unit tests, integration tests, acceptance tests, performance tests, canary tests, A/B tests, smoke tests, code coverage checks. There are many different kinds of tests you can run. And most pipelines will run more than one of these. And we'll get outputs like the test results and test coverage reports. In a package step, we'll create software artifacts that will be published. Things like container images and their image tags and image digest and archive files will come out of package steps. In the tag step, we'll annotate source code and artifacts and images and so on with information such as the version number and description. So this is like generated metadata, and we're going to tag it. So for example, we might be adding tags to a certain commit or version in our source code management system or in our image repository. In a publish step, we'll upload software artifacts and documentation to another repository. We may also update various catalogs or mirrors of the repository. We might update our release notes. So this might be called push or upload or release as well. So that's your really basic pipeline. You'll do most of those. And now the next thing is, okay, now we want to add provisioning and deployment to our pipeline. And this is where we make the leap from continuous delivery to continuous deployment. Sometimes we'll have different tools for the CI and CD stages, but some tools will support everything in the pipeline. In a provision step, we're going to request that a new physical or virtual server be made available for us to install or update software. Or it might provision networking resources or other resources as well, like a test cluster or object storage. In a deployment step, we'll make changes to any environment other than the pipeline environment. We'll configure the environment, we'll deploy the dependencies that we need, and then we'll deploy our own software artifacts and or documentation. This might also be called install or configure. And as an output, we'll usually get back routes to the new deployments with connection info, as well as any deployment records or maybe secrets that we need to access our newly deployed resources. Then we verify the deployment to make sure it was successful. Sometimes this is called a smoke test. And as inputs, we'll use those routes and secrets that we got from the previous step and run some quick tests against the environment, and we'll get back our deployment verification results and records. Then a cleanup step is very important, especially if you've been deploying resources. This is where you're going to release pipeline resources, deprovision environments, delete pipeline workspace and pipeline containers, and things like that. Sometimes it's called finalize or finish. Now let's talk about what you can do to add DevSecOps and supply chain security features to a pipeline. So once we have the basics working, that's usually the next thing we want to do is automate security and compliance work, because that can get really tedious. Secret detection detects secrets in the source code, other software, or documentation. For example, if somebody accidentally commits a password or an SSH private key or something into their source code, there are tools that can detect that automatically for you. Interesting side effect of this is that the tools are often capable of also revoking the secrets automatically, which is honestly a great feature because it protects developers from leaving a hole in your environment, a security hole, and they'll usually notice the problem more quickly when their keys stop working. A dependency discovery step is where you perform a deep discovery, like a recursive discovery of your dependencies and their dependencies to identify everything that your software depends on as packaged. And it produces either a dependency list or a dependency graph or tree as output. Now this dependency list may go into something like a lock file, which will guarantee that your build and deployment are using the same exact versions of your packages. It can also be used in a bill of materials. And it can also be used actually to check for known vulnerabilities. Speaking of a bill of materials step, this is a step where you're going to create a software bill of materials for a given repository that captures the pedigree of all of your dependencies, and it's collected at different granularities. So this is sometimes called a BOM or SBOM or build BOM or output BOM step. And this is important in supply chain security. A remediate step is one that can find and automatically fix known vulnerabilities for application package dependencies, container-based images, and operating system packages. Often what a remediate step will do is search your dependency list or graph for dependencies with known vulnerabilities, then look for a later version of those dependencies that's still within the range that's specified in your package list, automatically update to that latest version, and then rebuild and retest. Interesting side effect, it might also go ahead and update your source code repository with the new dependencies. Or maybe it'll create a pull request with the updates for a developer to review and merge. Or it might use APIs to request an update. Or it might open an issue to request that a developer fix the updates. In the case of mutable infrastructure, this might actually cause a running system to be updated if you're watching. So say your mediate step actually generates a new container image and publishes it to your repository. Then you have another system that's watching for new versions in your published repository and pulling them into your production systems. This can actually happen automatically, which can be good or bad depending on how much you trust your testing. A scan step is where you use any tool to do verification of software and documentation other than testing. So examples of this include static code analysis, linting, checking for known vulnerabilities in your code or your binaries, dynamic security scans or DAS testing, license checks to make sure that the licenses of the software that you're using are compatible with what you're using it for, and code smells. In a sign step, you'll use a cryptographic method to authenticate the software. So the signature might also include information about the source of the software and how or where it was built and what level of approval it has received, like has it been approved for deployment to staging or production or so on. And as an output, you're going to get signed artifacts, and also you'll have records of the signing taking place. In a policy step, you'll verify that policies are followed. For example, you might have policies that your software has to come from a trusted source, or that your source repositories are configured correctly with, for example, branch merge protections. It can check that your dependencies have been signed, that code reviews have been completed, or that appropriate work items or change requests have been associated with the change before moving on to the next step. Interesting side effects that can happen here could include blocking a pull request or a commit so that it can't be merged until the policy is met, or it might discard or approve an artifact or image, or it might stop a deployment from happening. In a record results step, you're going to record and report on the pipeline results and your compliance evidence. And you can store pipeline artifacts for long-term archival. So here's an example of a prototype that uses these types of standard steps that I created in Tekton, so you can kind of see how it works. So you see here at the left, there's a setup stage, or step, sorry, and then it clones the source, it does a build, it packages things. It does a discovery of the dependencies, it generates a bill of materials, signs the artifacts, and publishes them. And also, while it's publishing, it can provision some resources for our test phases. And also in parallel, it can detect secrets and check some policies like that code reviews happened and that branch protection was enabled. And after we've provisioned and published what we need, then we can go ahead and deploy to our test environment and verify it. And we can do some scans like twist lock and some acceptance tests and dynamic security testing. Then we're going to clean up our deployment and record the results of that. And at the end, kind of cut off there, we'll send a Slack message to the team reporting on how it went. Also up here, there's some more things that happen after the bill of materials and unit tests, like we're doing checks for policies to make sure that they were met. We're checking for proper code coverage and doing some linting and so on. Also, yeah, detect secrets is down here. And there's even more available. So in an analyze step, you provide additional processing and analytics based on the results of a previous activity. Sometimes these are called things like metrics, score, grade, or parse, and it will generate some kind of analysis report that can either be used for further automation or for people to just watch and see what the health of the system is. A message step is where you're going to send a message to another system, for example, a Slack message or an email. We have another type of step called create request that's different because the pipeline doesn't necessarily need to store a link or handle for the message. It's just a send it and forget it sort of thing. An update record step will update a record in another system. For example, it might update and close a change request after the deployment to production has completed, or it might update a GitHub issue with the results of a check of one of your policies. In a run step, we'll run a script or a program that doesn't fall into one of the other categories, and this often executes in another container that might be downloaded separately. This is something that is very powerful, but you have to really watch out for it from a security perspective, because whatever is in that container or script will happen, and it can be very difficult to sort of put a sandbox around what those are allowed to do inside of your build system. And as organizations continue to mature and advance in their CI/CD pipeline maturity, they start to add even more pipeline stages. So some examples of those might be OSS, open source introduction, open source storage, open source consumption, and so on. So here's a little peek into some research we're doing right now, trying to make more pluggable Tecton pipelines. Our use case is that as a provider of CI/CD pipelines, I want to create a policy that requires my pipelines to verify certain things, but still be able to replace one implementation of a type of a step with another implementation. For example, our pipeline should be able to automatically run the tests and gather the evidence that we need for security and audit, and to make sure that we're passing the checks for our policies. But in reality, most developers need to customize their pipelines, and there are different tools that are used by different organizations. People use different programming languages, so there's really no one size fits all. And if you try to write a perfect uncustomizable pipeline for everybody, you're just going to end up with 50 different pipelines that you're maintaining. So the solution we want is that we can chain together trusted steps and tasks into a customized pipeline, while still knowing that the steps were trusted and that we know what the steps we're checking. And in order to do that, we need standard step or task types. So this is a starting point that lets us build what we need. Thank you for listening to my talk today. Please feel free to reach out if you want to chat more about CI/CD, Tecton, DevSecOps, supply chain security, or the interoperability SIG. You can reach me on LinkedIn or Twitter.